Hey guys, welcome back to Chemistry Uncovered, episode 18. Welcome. Yo, with all due respect, you do not interrupt your teacher during class. What is your name?
Chemistry Uncovered is my name.
Okay, you may sit down now. Let's get down to business. So, as you guys all may know, actually you guys probably don't even know this, but most of you guys watching aren't even subscribed. It's almost the percentage of you guys who are subscribed, who are watching, is almost as minuscule as the percentage of the nucleus inside the atom. What are you guys doing? Subscribe. Hey, what do you want?
I'm sorry. This is kind of boring though. I kind of want some fun chemistry.
Okay, I'll give you pH chemistry. So, to start off, you guys may be asking, how do we determine whether something is acidic or basic? How do we determine the acidity of lemon and lime? And how do we determine how acidic the ocean is? Right? Well, in 1909, the Danish chemist Søren Sørensen, sorry if I'm mispronouncing that, set out to answer these questions at the Carlsberg laboratory. Through empirical laboratory studies, he embarked on a journey to quantitatively measure hydrogen ion concentrations in not only aqueous solutions but also liquid solutions. Thus, the term pH was born. Now, fun fact, when the term pH was coined, H was originally a subscript of P in comparison to H being uppercase and P being lowercase now, right? So, the goal of the video is to build off of the acid-basis video a couple weeks ago in order to uncover the mysteries of the pH concept and how it is applied in the world around us. In addition, we want to outline future pH labs that we are going to do on this YouTube channel, such as the pH paper lab and the rainbow test tube lab, so stay tuned. Now, pH is used to measure the hydrogen ion or hydronium ion concentration, ranging from 1 molarity to 10 to the power of negative 14 molarity. Now, I am going to switch to this whiteboard background really quickly to show you guys how to calculate pH and pOH. First of all, if we have the hydronium concentration, we can use the equation pH equals negative log 10 hydronium ion, right? And then we can use the inverse of this equation to find the hydronium ion concentration from the pH, which is just 10 to the power of negative pH. Similarly, if we want to find the pOH, we can do the same thing but with hydroxide, with the hydroxide anion, right? So with this, it's just pOH equals negative log 10 OH minus concentration. And the OH concentration from pOH is just P 10 to the power of negative pOH. To combine these, right, pH plus pOH always equals 14 because 14 is the maximum on the pH scale, right? And so using these equations, we can always interchange between either pH, pOH, hydronium concentration, hydroxide concentration to find whatever value we want to find. So a common question I get asked is it possible to have a pH less than 0 or greater than 14? And the answer to that is yes. It is always possible. If you have a hydrogen ion concentration greater than 1 or less than 10 to the power of negative 14, then your pH will be either less than 0 or greater than 14. So it is possible. Now onto the real world application, right? Outside of ocean acidity, pH is a critical function to soil acidity and crop productivity, right? Using soil pH meters, The quantitative measure helps determine which crops will grow properly, and if not grown properly, the adjustments we should make to increase crop production. Soil acidity is considered infertile for many crops. However, many crops such as those in the Ericaceae family don't prefer alkaline soil either, meaning they don't prefer basic soil. Soil acidity increases from increasing carbon emissions, organic microbial actions like bacteria, fertilizers that hydrolyze and nitrify, and oxidation of sulfur compounds such as sulfuric acid. With the increase of this acidity, metals such as aluminum and magnesium become more soluble, and plants cannot tolerate high metal concentrations in soil. Metal activity is increasing at a faster rate than ever before because of industrialization. Lime juice, which is basic, can act as a remedy though that can neutralize acidifying soil. Thank you guys so much for watching this pH video. We have some fun labs coming up in the next few weeks. One is a pH paper lab. The chemistry behind this is that pH paper has a chemical anthocyanin called flavin. Flavin is found in different fruits such as blackberries, blueberries, and also vegetables such as red cabbage as a pigment, right? Flavin is also a halochromic pH indicator. Halochromic meaning that it changes colors as different pH level solutions such as lime juice, lemon juice, coffee, detergent are applied onto the paper. So stay tuned for the upcoming weeks for this lab. And the second one, maybe my favorite, is the pH rainbow test tube lab. This experiment involves adding a hydrochloric acid, a strong acid, and a strong base, sodium hydroxide, into two different ends of a test tube, transparent test tube, right? With a universal indicator already previously poured inside the test tube. This universal indicator is also halochromic, indicating that when we add HCl and NaOH on different ends, the universal indicator starts to change colors based on the pH levels in different levels of the test tube. So you guys will see a rainbow color being formed. Stay tuned for the upcoming weeks for these two amazing lab experiments. Thank you so much. And as I will end every single video saying, please make the world a better place. Do your part, do your duty. Use this pH knowledge, make the ocean less acidic, make the soil less acidic so that we can have more crops. We can produce more crops for our own nutrition. There are a million different ways to achieve the goal of the phrase I put on this slide, making the world a better place. So find your mission. And thank you so much for watching. I hope you guys have a great day and see you guys next week. Peace out.